Okay. Yeah. So the yes and no poll that you might see on your screen is to just check if you are able to retrieve the link to the materials on the meeting chat on Zoom. If not, you can also just scan the QR code on this slide of the screen that you should be able to see. Okay. Then I will yeah, just share only 8 told me that they can link. Okay, then. Yeah, I think it's already 2 minutes into the meeting time. So let me begin. Okay. So there are about 22 of you now. Okay, welcome. This is the Set 4 Combined Science, just the chemistry portion of the WA1 revision. I'm Miss Abigail. Hold on, let me... sorry, give me a while to connect back to my PowerPoint slides. Okay, yeah. So I'm Miss Abigail. I am currently teaching Sec 4 Science Chem Bio, Sec 3 and Sec 4 Pure Chem. I used to teach IEP Chemistry last year to the Nanyang Girls cluster, and I also had additional math classes. So some fun facts about me besides teaching chemistry. Sometimes I like to play balsas. I like to make a cup of latte for myself each morning, so that helps to keep me awake. And then I'm into bird watching. So if you can see the owl over there, it's an owl that I saw at Bidadari Park. Yeah. Okay, I have actually some students with me that stayed back after my lesson just now. So just giving an introduction of the company. Okay, so we actually have 7 branches across Singapore. Currently, today I'm at the Tampines location, which is just newly opened sometime last year in September. Yeah, so we have a number of branches. The latest one is in Bishan. We hope to open more locations to reach out to more of you across Singapore. Okay. If you'd like to actually get more free content, you can scan the QR code here to join our OVERMUGGED channel. Yeah, where periodically we'll upload more links like more links to revision events like this. We'll upload free notes, free materials for you. Okay. Results. I think most of you want to see results. Okay. Yeah. So personally, these are like some of my students' results. Just for this year O levels. So I'm happy that they managed to work very hard. Most of them actually are like Sec 3s going Sec 4. And then when they joined, results weren't too good. Like maybe failing or just pass. Right. But over the year, I think we managed to work together and we got the results that we wanted. Yeah. Okay. So the resources that we have, we provide our regular students with curated notes. So it will be a booklet of the chapters from Sec 3 and Sec 4. Then now we have this WA revision event. Okay, closer to the middle of the year and towards where you take your O levels, we also have mock examinations for you to prepare yourself to be comfortable with the time allocated, such that you work fast, you manage your time within the time constraints. Okay, and then we are also quite big on doing practicals. So for both pure and also like combined science, we have practical sessions for you to have your hands on all the different experiments that will get you prepared for your O levels. Okay. Okay, so without further ado, right, I will not talk so much. I will start the session. So now I'm just gonna let me see, connect my screen to my iPad. So you should see, hold on, me and the show, okay, yeah. Okay, so I have two handouts as mentioned just now. This is the first handout. And then the second one is the one with the questions. Okay. If you are ready, can I just get everybody to type 1 in the chat? If you are ready. Okay. Right. So we'll be covering mole concept and stoichiometry, as well as reactivity series. Okay. So we have the created notes attached. Okay, so without further ado, right, over here, for mole concept and stoichiometry, hi, sorry, is there a QR code to download the worksheets? Can I just give you the link? Is that better? And then for those whom we just joined, this is the link. Okay. Okay. So a quick recap. All right, over here, oh, some just joined. Okay. Okay, for mole concept, the first thing that we need to recall is from the periodic table, we are given the relative atomic mass of an atom. Okay, you got to memorize the definition. Is the average mass of one atom of the atom compared to 1/12 of the mass of one carbon-12 atom. So essentially 1/12 of 12 will give us 1. Okay, and since this is a comparison, there will be no units to the relative atomic mass, or for short, AR. Okay, so this is only for one atom of the element. Once you have, for instance, okay, so oxygen, right? If I was referring to this earlier, the AR of oxygen would be 16. But when I move over to the gas, which is oxygen, now it exists as a molecule. Then I'll no longer write down AR, but I'll write MR. So MR of oxygen is basically going to be the sum of all the ARs of all the atoms present. So this will be 16 times 2, and that gives us 32. Okay. So I will be careful of whether I'm writing MR or AR. Okay, but honestly, I think some of you will just keep using MR, right? So just take note of the difference. Okay. So for the phrase here, relative molecular mass, there's one more, which is relative formular mass. So this applies to different substances. For molecular mass, I'm looking at covalent substances. Can be a covalent element or covalent compound. So as mentioned, for example, oxygen, maybe even ozone or nitrogen, versus for compounds, let's say for example, nitrogen dioxide, sulfur dioxide. So these are all covalent. If I'm looking at an ionic compound, they don't exactly exist as molecules. Okay, so the word here to use is relative formular mass, even though the symbol is still MR. Okay, why formular mass? Because if you're looking at Na plus and Cl minus that makes up sodium chloride, I don't exactly really have one Na plus and one Cl minus. We have a lot of ions, right? And they are actually arranged in a giant ionic lattice. But for the simplicity of calculating the MR, we just take it as one Na and one Cl. Okay, so there's a very slight difference here. Okay, then as we look at moles, one mole essentially represents 6.02 times 10 to the power 23 particles. So these particles here will be grouped together for us to actually calculate more simply. Right, 1 mole, 2 moles, it will just be multiples of 6.02 times 10 to the power 23 of the particles. Okay, in terms of particles, then you have to be specific in identifying, are they atoms, molecules, ions? For some of you, maybe if you have already learned about redox, then we can bring in electrons. Okay, for example, we say that perhaps sodium, metal, if it loses an electron, then it will form a cation. right? So I can say that I have 1 mole of sodium actually losing 1 mole of electrons, and we will get 1 mole of sodium ions. So all these, 1 mole essentially is equivalent to 6.02 times 10 to the power 23 of each atom, ion, or electron. Okay. Moving over to the next page. So where AR and MR are in concern, we are looking at those numbers without any units. Okay, but when we do our mole calculations, which some of you have been doing, we are looking at the molar mass actually. And that is the mass of 1 mole of that particular substance. Okay, the units for molar mass is grams per mole. Essentially, is the mass of 1 mole per mole. Right? So based on this, we can actually bring in molar mass and then the conversion from moles to mass. So usually when I teach this at the beginning, what you can do is to look at this. If I have number of moles, I want to find mass, right? You have either 2 choices. One is to multiply or the other is to divide. Okay, if somehow you say multiply, oh no, sorry, somehow you say divide. Okay, when you have a number of moles, you divide by molar mass, you are eventually going to get something like moles, you divide by the mass over moles. Okay, if you recall math, right, this is actually moles, then the division sign, when I change it to multiplication sign, I'll get moles over grams. Then this will work out to be something like mole square, then divide by grams, which is a foreign unit. Okay, so in fact, if I just look at moles, I want to convert to mass. I'm not going to put divide, but I want to bring out the mass, right? To get mass, I multiply by molar mass. Then that gives me the correct conversion. Okay, and likewise, if I have mass, I want to find moles. This is the quantity that I'm going to use, molar mass. It will not make sense for me to multiply because mass times mass will give me mass squared. Okay, so in that sense, if I want to remove mass, get rid of mass, right, I should be dividing by the molar mass. So in that sense, mass divided by mass, I'll just get moles. Okay, so you can actually, I mean, if this helps you, you can use this to figure out, do I need to multiply or divide by mass, but the molar mass. Okay, so the molar mass is from the periodic table. Okay, some of you are more familiar with mass divided by MR, right? So I will not stop you from that, but the better formula will be mass over molar mass to give you moles. Okay, one thing that you have to take note of, mass must be in grams. Okay, so conversions, if question gives you kilograms, then this is to multiply by 1,000. All right, and very, very low chances, but I cannot rule that out. If let's say we have 3 tons, we will need to multiply by 10 to the power of 6. Okay, 1 ton is 1,000 kilograms. So if this is like 3,000 kilograms, then we need to times another 1,000 again. So this gives us 10 to the power of 6, essentially. Okay, but I'm thinking most of the time questions will state this. Stated in question. The next one that we have gases specifically. So for molar volume of gases, this is where 1 mole of any gas will occupy 24 dm cube or 24,000 cm cube. All right. So similarly, if you consider, I have number of moles of gas, I want to find the volume of gas. So remember, this is the molar volume, right? Do we multiply or do we divide? If I want to bring out the volume, okay, we should multiply. So the molar volume at O levels will be 24 dm cube. Okay, so this is to multiply 24 dm cube per every 1 mole of a gas. So same thing, if I have volume of a gas, I want to find number of moles, then ideally I don't want to see volume anymore in my answer. I will need to divide by volume to like cancel away the volume, okay, to just show the number of moles at the end. Okay, moving on, we have concentration. Concentration will refer to solutions only. All right, most of the time we have the solvent to be water. Okay, so what's this? Solvent would be water. The solute is usually the dissolved solid, okay, or dissolved liquid, or maybe even dissolved gas. So this one can be solid, liquid, gas. Okay. For solid liquids and gases, here the quantity that we'll use is either mass or moles. All right, so actually there are two types of concentration. This is known as the mass concentration if the units is gram per cm cube. Okay, we are on page 5 of the worksheet. And the other concentration is the one that we are more familiar with, molar concentration. Okay, where the units is moles per dm cube. Right? This is the formula that we will need. Most of the time, questions will very, very likely give us concentration and volume. But the concentration, the problem here is that they always give us in cm cube. Right? So for example, 25 cm cube. And the concentration, most of the time given to us could be, always in mole per dm cube. Okay. So for example, I have 2 mole per dm cube. Right. So how do we work out the number of moles? Always convert the volume to dm cube, where you must always divide by 1,000. Okay, so in dividing by 1,000, that gives us the new like converted volume to dm cube. Then this is where you can actually compare the units. I have dm cube. This is moles per dm cube. All right, or if you look at it in a mathematical way, right, dm cube like over 1, and then I have mole per dm cube, which is also equivalent to moles, then divide by dm cube. If I multiply them together, I'm going to cancel out dm cube, right? Then that leaves me with just moles. Then effectively overall, I can actually find number of moles by multiplying concentration and volume together. Okay. Then this is where, if we use this as this is the foundation of the formula that we have, right? We can always find concentration is equals to, keep this on the right hand side, bring over volume, right? And that will give us moles over volume, which is equivalent to moles divided by volume is in dm cube, right? And this will be consistent with our units of molar concentration, which is moles per dm cube. Okay, and of course, if I want to find the volume instead, keep volume on the right-hand side, bring over concentration, I'm dividing moles by concentration. Okay, so use this, and then you can actually just manipulate. If it takes you a while to manipulate, it's fine. As long as you get the correct answer, you multiply or you divide correctly, that's more important. Okay, don't have to memorize, please. Okay. We'll move over to, oh yeah, wait, let me just get you to take a look at this. Okay, I'll give you an example. Say I have hydrochloric acid, right? And I tell you, okay, I have this solution which has 1 mole per dm cube of this concentration here. Okay, what will be the mass concentration? Okay. So based on this, if you look at the formula, maybe it looks complicated, but basically I have moles. I want to just convert to grams. So moles convert to grams, actually you have already covered in the previous part, the very first formula. Okay, if I want to find mass, I can take moles times molar mass. So for hydrochloric acid, if I want to convert to the mass concentration, right? So actually, I'm just going to multiply by the molar mass. So for hydrochloric acid, hydrogen has a mass of 1, chlorine a mass of 35.5. So the equivalent concentration will be 36.5 grams per dm cube. All right. Okay, so I will just upload the annotated notes at the end because I have one request from L. Okay. Okay. For the this chemical calculations page, I will not cover the notes section over here. All right, I will just remind you on page 8 at the top of the worksheet. It is very important over here to just take note that if you are comparing gases, okay, so these three, right? If you're comparing gases, then essentially because the number of moles of any gas is going to give you the same volume of any gas. So for example, 1 mole of H2, 1 mole of oxygen, 1 mole of CO2, 1 mole of, let's say, nitrogen dioxide. Okay, all of them will all occupy a volume of 24 dm cube. There is no need to think so much. They will just occupy the same volume, right? But if I ask you for the mass, it's going to be different, right? So the mass for 1 mole of hydrogen, then you have to count the MR. This is 2, oxygen is 32, carbon dioxide will be, for me I memorized already, but it will be 12 plus 2 times 16. Maybe some of you have started to memorize. Okay, for nitrogen it is 14, then plus 32. So 14 plus 32, 46. Okay, so that's why also we always compare mole ratio and even volume ratio for gases and gases only. We cannot and we can never compare the mass ratio. Okay, because as you can see, 1 mole of all these gases will occupy different masses. So even more so for like other solids and liquids also. All right, if this is not emphasized to you enough before. Okay, so I will go over to page 10, all right, of this set of worksheet. Okay, so on page 10, we have a couple of MCQs. All right, so for question 1, actually this question to begin with is actually quite challenging for an MCQ, worth just 1 mark. Okay, so here we go. We have a sample of 40.5 grams of metal oxide. It is reduced to 32.5 grams of metal, which is just X. Okay, how is this possible? Metal oxide, XO. What can we identify from this? Metal and oxide, right, means they form an ionic compound. Yes. So oxygen forms oxide ion, O2 minus. The metal is going to have a charge of X. Can everyone type out in the chat what is the charge of X? What is the charge of X? If you know, can you type out the answer? Huh, no one knows. Hmm? Yeah. Mass is? Oh no, that is not the correct formula. So if that's what you get right, then you multiplied wrongly. Yeah. Okay, thank you, Alicia and Umaira. Yeah, 2 plus or plus 2? Okay, plus 2. All right. So based on this, XO, this metal is reduced. Anyone learn redox already? Okay. Reduction, there are many definitions. There are 4 definitions. Over here, I think if we look at this context, this will just be the loss of oxygen. Okay, so basically oxygen is lost, then that's where we can get X, metal X, right? And together over here, to make up this equation, after all, oxygen, now you have to ask yourself, does it exist as O atoms or is it something else, right? Is oxygen atoms stable? Or what do I have? Okay, then you need to identify, actually we need to have oxygen being produced or like lost. Okay, now according to this, then we need to balance the equation because oxygen is not balanced. Okay, so upon balancing, put 2 in front of XO and 2 in front of X. All right, so that we have 2X and 2 oxygen atoms altogether. Okay, now this is the part that for your mole concept, right, and stoichiometry, very importantly, I think we need to see that, okay, the mole ratio is 2 to 1. Okay, this is crucial. Now, when we bring in our information, we have 40.5 grams of XO, right? Can I find the number of moles? Cannot, because I don't know what X is. And in fact, I need to find out what it is later. Okay, so I am stuck here. I cannot divide by the MR or the molar mass to find number of moles. Cannot. Okay, so I'm not able to proceed here. Now next, I have X, metal X. This is going to weigh 32.5 grams. Similarly, I have X as a metal. If I divide by the AR or the molar mass, I can find number of moles. But again, I am stuck. I don't know what X is, so I cannot proceed. So what do we need to do? Here, this is where you need to realize the big picture. Metal oxide gives you metal and oxygen. So you need to find the missing link, you subtract. You find the mass, the difference in the mass. So 40.5 grams minus 32.5 grams, the difference is a mass of 8. Okay, so that means actually now I have the mass of oxygen. Do I have the MR of oxygen? Right, O2, I know. Oxygen has a mass of 16, O2, MR is 32. So now when I divide by 32, the molar mass is 32 grams per mole. Then I actually am able to find the number of moles of oxygen. Okay, that will be actually a quarter. A quarter is 0.25 moles. All right. Now I am able to find X. Okay, how? This is the number of moles. Then don't forget, we found out earlier already from our balanced equation, the mole ratio is 2 is to 2 is to 1. Okay, so actually, I will just look at X itself. So knowing the mole ratio is 2 is to 1, then that means now I have to times 2 to find the number of moles of X. Okay, 2, so times 2, because of the mole ratio, 1 is to 2, so 0.25 to 0.5. Right, and now overall, I have 2 quantities, mass and moles. I can find the AR or the molar mass now. Right, so if I have mass, I have moles. Mass is 32.5 grams. The number of moles is half a mole. So here you can either take mass over moles. That will give you the molar mass. Okay, some of us, maybe we approach this in a mathematical way. Half mole, the mass is 32.5 grams. So 1 mole I times 2, right? So this one also times 2. Then that will give us the answer of 65. 32.5 times 2, so 65. Right? If you have an open-ended question, the question might ask you, what is the identity of X? Right? Look at your periodic table. look at the correct number, it will actually represent zinc. All right, and then just to give you a, if you recall, what is the type of oxide here? Zinc oxide. It will be amphoteric. Okay. Okay, moving. So this question is slightly longer where you have to go and balance the equation, right? Second one, it's simpler. Solution of nitric acid is made by dissolving 31.5 grams of nitric acid, HNO3, in 200 cm cube of water. What is the concentration in mole per dm cube? Okay, so when you encounter a question like this, don't panic. Just look at, first of all, this is the mass, right, of nitric acid. What you should do is to find number of moles. So for the molar mass, do you multiply or divide? Okay, you have the mass already. Should I multiply or should I divide? Okay, it will be 2. Get rid of mass, so we need to divide. So divide by molar mass. So look at the periodic table. Nitric acid, HNO3. H is 1. Nitrogen is 14. We have 3 oxygen atoms, 3 times 16. Okay, that works out to be I don't have my calculator here, but 48 plus 14 plus 1, that will be 3, I think 63. 63, okay, grams per mole. So actually 1 mole, right, will weigh 63 grams. Mathematically, how many moles will weigh 31.5 grams? So 31.5 grams is like half of 63. But of course, you just take 31.5, we divide by 63. Okay, that will give us half a mole. Half, I won't write down 1/2. I prefer to leave my answer in decimal place, 0.5. All right, now overall, I'm very close to my answer. Here, I actually have 0.5 moles, but in 200 cm cube of water. Okay, so if I want to convert to mole per dm cube, there are 2 ways. The first way, using the formula, so the concentration will effectively be the number of moles divided by volume. So number of moles is 0.5 divided by volume. Volume must be in dm cube, so 200 over 1,000. All right, and then this will give us 0.5, sort of like times 5, which is 2.5. Okay, mole per dm cube. And then our answer will be C. The other way, because this is actually like MCQs after all, right? Okay, you can also do this. In 1 dm cube will mean 1,000 cm cube. So it could mean I can just multiply by 5. If I actually have 5 times of 200, right? This is times 5. So 0.5, I also times 5, and then that will give me 2.5 mole per dm cube, which is actually kind of like what I did over here as well, when I divide by 200 over 1,000. Okay. Any number that is more than 1 mole per dm cube is considered quite concentrated. So in labs, I think at the moment and in your schools, you will not deal with such concentrated solutions. If you have to, please use a pair of gloves. Okay. Question 3, it will be a very similar question. Okay, so here is just to identify the correct quantity of the concentration. Okay, but I'll just give you an overview. So if you have a solution, all right, made up of like using 9.5 grams of magnesium chloride dissolved in 100 cm cube of water. Okay, more of this, when I actually split this 100 cm cube of solution into 2 beakers, what will change? What remains the same? When I separate them, okay, the concentration will remain unchanged. All right. So I need you to actually take note of this. The concentration of both solutions will be the same. Right. What will differ So I give you an example. So let's, okay, I think we can actually calculate. So the MR of magnesium chloride, magnesium is 24. We have two chlorine like atoms here. So it's 2 times 35.5. 21 plus 24 would be 95. Okay. Usually the values that are given to you are quite nice, right? So this is 95 and this is 9.5. So number of moles will be equivalent to 0.1 moles. Okay. But this 0.1 moles is dissolved in which volume? Only 100 cm cube of the solution. Okay. So 0.1 moles, but in 100 cm cube. So let's convert to dm cube. Okay, or the other way is to check. To convert to 1,000, I need to times 10. So that means 0.1, I will also times 10, giving me 1 mole per dm cube. Okay, this will be the concentration of the solution in this conical flask. 1 mole per dm cube, right? So as mentioned, the concentration will be the same. This is still going to be 1 mole per dm cube and 1 mole per dm cube. But what is going to change is, because the volume separated is different, the number of moles inside are also different. Okay. So based on this first, all my answers are in gram per dm cube. So for the concentration wise, if we check back, MgCl2, right? What is the mass of 1 mole of that substance? 1 mole has a mass of 95. Okay, 95 here. So if I want to convert to mass concentration, then this means to multiply by 95. So again, this will be 95 grams per dm cube and also 95 grams per dm cube. Okay, so the answer that we will choose will be D. Okay, moving on. Right. Now for these two questions, if we look at the first, question 4, so we have aluminium. The question here has told us the MR is 102, so we don't have to calculate. What is the volume of oxygen needed to produce 102 grams of aluminium oxide? So again, actually over here, when we consider this type of questions, please, if you have a highlighter or if you are just more used to underlining, you can always underline, circle, box up your reactants. Okay, so I'm looking at aluminium oxide. Okay, one more thing. Aluminium is in group 13. So the ion is Al3+, all right, and oxygen is O2 minus. So 102 grams of aluminum oxide with the MR of 102 actually tells us that it will just essentially be 1 mole, okay, of Al2O3. So in MCQs, this is 1 mole. I do not touch the stoichiometric coefficients. I don't look at the 4 and 2 and 1 here. Okay, when I just calculate mass over MR, I solely look at this number, this formula here. Okay, but now when I want to answer the question, what's the volume of oxygen needed? So oxygen, right, I'm going to compare. Okay, so the mole ratio of, so this is if you write out in your FRQ, your free response questions, we compare mole ratio, look at the numbers in front, it is 2 to 3. Okay, and now as we bring in the number of moles, 1 mole of Al2O3 will actually need to react, will need oxygen to react, in this case, in the 2 to 3 ratio as well, which is 1.5 moles. Okay, and now how do we convert to volume? Right, so moles, volume, gas. So we need to bring in the molar volume. So check, I have moles, I want to find volume. I've got molar volume, which is 24. We need to multiply, all right, so that we can bring out the volume. So take 1.5 times 24, and that will give us 24 plus 12, so 36. Okay. Question 5, another similar question. We've got 3.8 grams of magnesium chloride. I'll just use the value previously. Just now on page, on question 3, MR of magnesium chloride is 95. All right, so I don't have to like redo again. Here I know the MR is 95. Okay, so I've got mass in our calculator. Let me just pull out my calculator on the screen also. Right, so you'll be able to see over here, 3.8 grams. If I want to find moles, I need to multiply or divide by molar mass. Right, this is already mass. I want to cancel the mass, so divide. Okay, so in my calculator, I put 3.8. Whoa. I divide by 95. All right, and then the value here, what we will have is 0.04 moles. Okay, so MCQs work fast. We are reacting with an excess of aqueous silver nitrate. So essentially, MgCl2 is the limiting reactant. Therefore, it will actually determine the product's form. Okay, and the product that we're looking at is silver chloride. Silver ion is Ag+. Okay, so do take note, silver is Ag+. Then chloride is just Cl-. So that's why we get the formula of Ag, Cl2 here. Okay, so as we compare the mole ratio is 1:2. So that means 0.04 moles of magnesium chloride will react to give us 0.08 moles. And therefore, we can actually derive our answer. How to find mass? So if I have 0.08 moles of AgCl, you need to go and look at the periodic table. Okay, mass, right? Molar mass for silver is 108, and then chlorine is 35.5. 35.5. All right. If I want to have the mass, then multiply or times, right? Mass and mass. Now it's moles only, so multiply. Okay, and we get 0.08 times 108 plus 35.5. Okay, then our answer 11.48. I'm working faster because it's MCQ, right? And you have to work at this speed also for MCQs, because 1 mark is only worth about 1.5 minutes long, especially for, okay, it's understandable for moles. You might take a bit longer, right? Because some questions you take like what, less than 10 seconds. So for moles, we take a little bit longer, but not too long. Okay, not like what, 5 minutes. If you're doing questions at 5 minutes, you have to find the right speed. Okay, next question. So as we move on to solutions, right over here, I have to find the volume of a solution. I already have the concentration. Okay, so maybe when you're looking at this, right, I need to find volume. So how? So if you recall again, moles for solutions is concentration times volume. So that means at the end of, or like towards the end, I need to find volume. I keep volume on one side. I need to take moles, divide by concentration. So this will be the formula that I'll fall back on at the very end, right? So if I need to know the volume, I have concentration. So this is what I should be finding, number of moles. Okay, now with 15.2 grams of iron 2 sulfate. So iron 2 sulfate is FeSO4, where iron is Fe2+, sulfate is SO4 2-. All right, so according to this, I need to first find the molar mass, the MR for iron, 56. Okay, sulfur is 32, oxygen 4 times 16. do the math over here. 56 plus 32 plus 4 times 16. Right, it will be 152. Okay. So again, very nice. 15.2, I have the molar mass. That means 1 mole will weigh 152 grams. So this will be 0.1 moles, okay, of iron 2 sulfate. So with that, I've got my number of moles of iron 2 sulfate, right? In MCQs, I can just write down, okay, if this is 0.1 moles, then actually for sodium chloride, I am just going to multiply by 2 according to the mole ratio. Since this is 1:2, right? So times 2, 0.2 moles. Then that's where I can substitute 0.2 here. And then the concentration was what's given from the question, 1 mole per dm cube. And that will give me 0.2, but my units is in dm cube. Okay, so please pay attention to the units. Do not choose B. You need to convert to cm cube times 1,000. Right, and that would be D as the answer. Okay. Next one, question 7. Okay, over here we have a question that doesn't give us the state symbols. In time to come, you will learn about organic chemistry. For ethane, this exists as a gas. Okay, oxygen is definitely a gas. Carbon dioxide is a gas. But H2O here, it can be ambiguous. It could be a liquid, it could be a gas. Okay, here we will need to consider the phrase at room temperature and pressure. So this is very important. It tells me, or it helps me to recall that, okay, room temperature at O levels is 25 degrees Celsius. So H2O exists as a liquid. Okay, even though this is the burning of ethane. Right? So now, more importantly, when I look at the question, I read it, what is the total volume of gases, the gaseous products that are obtained when 0.5 moles of ethane is burnt completely? Okay, so the gaseous products, actually, we are referring to only carbon dioxide. Water is not part of the gaseous products that we should look at. Okay, I don't have any other information. I only know ethane burns completely. So the idea is that it's going to be the limiting reactant. Limiting reactant, 0.5 moles, right? So over here, if we have 0.5 moles of ethane, the mole ratio is 2. And for carbon dioxide, it's 4, right? 2 to 4 times 2. So that actually gives us 1 mole of carbon dioxide, right? And therefore, 1 mole of carbon dioxide, which is the gaseous product here, we need to multiply by 24, and that will give us C. Okay, multiply by the molar volume. Molar volume is 24 dm cube per mole of any gas. Okay, I will skip the questions for this, so you can retrieve the answers from the other file. Okay, I'm gonna go over to reactivity series. Okay, so as we move on to the reactivity series, this chapter over here, we'll actually come back to more moles questions later on. Okay, let's say you need more help with moles. All right. So for reactivity series, these are like the 4 outcomes. You need to know, first of all, the different metals and arrange them in order of reactivity. Then specifically, we need to know like the reactions with water, with steam, and also with acid. Okay, the acid that we are looking at is hydrochloric acid. So all 3 reactions with metals may occur or may not occur. Some can be very fast, some can be very slow, some do not react at all. Okay, for B, deduction of order of reactivity from a given set of experimental results. This one, sometimes we are looking more at displacement. Okay, so through displacement, we can actually identify which is more or less reactive than the other. Okay, and subsequently for C, we are looking at the obtaining of metals from the ores. Ores are actually compounds. To put it simply, the compounds can be oxides, can be different types, can be carbonates also. Okay, basically you have a metal in a compound and you want to extract the metal. Okay, and the last part we'll look at corrosion, specifically for rusting. So just need to take note that these are the two requirements for rusting to take place: oxygen and water. Okay, so for the reactivity series, this is one example that you can use to help you to remember this mnemonics here. Wait, let me just pull out the worksheet that oh crap, sorry. Hold on. Let me pull out the worksheet that I want to show you. Okay, here. So I just recently came back from Indonesia. Then I happened to see these two animals, which also is in line with this mnemonics here. Okay, please stop catching more zebras. Look at this zebra. Then I like hot, cute, short giraffes. So this giraffe is quite short. I think it was like maybe a few months old only. Yeah, so anyway, this will help you to remember the reactivity series. Okay, so potassium and sodium are in group 1. They are like the supermost reactive metals, okay, because they only just need to lose 1 electron to become stable. Next two are in group 2, if you realize. Okay, then subsequently, they are more of like the transition metals. We have zinc, iron, lead, hydrogen, then copper, silver, gold. Hydrogen is not a metal, but we place it here to help us to actually recognize which metals, the ones at the top, can react with acids. The ones at the bottom will not react with acids. Okay, so just remember copper, silver, gold, they will not be reactive towards acids. Okay, then as mentioned about the 3 reactions with water, with steam, with acid, all of them have something in common. They will produce hydrogen. Okay, H2 gas. For me, when I look at the reaction with cold water and the reaction with steam, okay, the one with cold water will actually give me hydroxide. So like this one has more syllables. It will produce a product with also more syllables. If it just produces steam, then it will produce oxide. Okay, so this one is 2 syllables, hydroxide 3 syllables. React with steam will give you the product with less syllables. Just add 1 plus 1 plus 1. Right? All of them will give us hydrogen. Okay. Next, we have displacement of metal. So this is very commonly tested. Essentially, in a nutshell, right, a more reactive metal can displace a less reactive metal from the salt solution. Right? And vice versa, it will mean that if I have a less reactive metal, less reactive metal, it cannot displace a more reactive metal from the salt solution. Okay. And if you recall about what you've learned in redox, then we can actually also bring in redox reactions where zinc forms zinc ions, right? This is in the form of Zn2 plus ions. So the charge or the oxidation state will increase from 0 to +2. Whereas for copper 2 ions, right, Cu2 plus, to form copper metal, oxidation state will decrease. Okay. The extraction of metals from the ores. So this was what I found from Wikipedia. This is an ore. Okay, an example of an ore. Doesn't look very metallish, but you can actually extract the metal from these compounds here. Okay, there are two ways that you can do so. One is to actually carry out electrolysis. This is like the most powerful method. You just use electricity. You're going to cause the metal cations to form the pure metal. Okay, and this only applies to the very, very reactive metals, which are the first 4. Right? Potassium, sodium, calcium, magnesium, the group 1, group 2 metals. Subsequently, the ones at the bottom, they don't need such a powerful method to extract the metals from the ore. So one way is to actually heat with carbon. Carbon here can be in the form of coal, usually coal. Another word that is used is also coke, but it's just another form of carbon. Okay, and then for the two metals, gold, platinum, typically they are found as pure elements. Okay, so that will be extraction of metals. And last, rusting. We need oxygen and water for rusting to take place. Rusting is only a word used for for iron. For other metals, you can say that they corrode. Okay, so we need water and oxygen present. If we have water that is being boiled, you are basically going to cause all the dissolved gases to be removed. They will escape. Okay, then the oil just prevents oxygen from entering. All right. If you add salt, basically salt is present. The ions will help to facilitate the rusting process. So here the difference between C and D, using distilled water versus sodium chloride, the iron nails will rust, but in the presence of ions like salt, rusting will take place more quickly. Okay. So there's the idea of like, I don't want rust to take place. I don't want rusting to take place. So what we can do is to coat the substance, either iron or sometimes steel as well. We can actually coat with a protective layer. Some protective layers may be just temporary. Paint, oil, plastic. These are just going to be effective unless the protective layer has a scratch or if it's broken. And that's the case, rusting can still occur because water and oxygen will be coming into contact with iron. Okay, so these are not permanent methods. A permanent method is to actually to produce stainless steel. That will be a better way to prevent rusting. All right, so let's move over to the questions. Okay. I think I'll pick out some important questions. And then I hope to have some time to do the open-ended ones. Okay. So for question 1, on page 21 of this set of worksheet. Okay. So based on this question, we are looking at the reactions with acid, steam, and water, right? Amongst 4 different metals. So usually what you should look at is cold water first, because cold water is the one that helps you to identify which is the most reactive. Okay, and that is the case for Y. Y is the most reactive. If I look at the order, sorry for the formatting here. So most reactive is here. I should put Y here. Okay, identify the easiest one to identify, and then I bet you can actually eliminate your options, which is C and D. Okay, next. Reacting with steam, not all metals can react steam also, only iron and above. So that means Z will come into the picture, right, now to be actually the second most reactive. So just based on this, right, I can get my answer to be B. And then I move on, right? But of course, if I'm looking at this going through, then for the acid reaction, when W reacts but not X, then that means that X is the least reactive. And if you look at the bigger picture, it doesn't react at all with any acid or steam or cold water. Okay, so here our answer will be B. Question 2, it's a similar question. All right, but now we add in another type of reaction, which is displacement. Okay, for displacement reactions, you must always check which metal you are adding and which is the solution that you are looking at or given in the question. So when I'm looking at S and it can displace Q, what this means or what I must identify is that S and Q, S is more reactive and therefore it can displace Q. Okay, so most reactive to least reactive, just based on this, right? I must have S before Q, S before Q, S before Q. This is not correct. This one's still possible answer. Okay, then from A, B, and D, the reaction with cold water, it's very slow for S, but R doesn't even react at all. So I can actually now identify that between these two, S is more reactive than R. All right, so I cannot choose D. I cannot choose, wait. I cannot choose, I cannot choose D. And then it's still a 50-50% chance for A and B. Now, according to what I observe for the middle portion, R reacts readily with acid but not Q. That means R is more reactive. So R should be more active than Q. Then that will give us our answer of A. Okay. For question 3, for this reaction, we'll see in the open-ended question as well. Steam is passed over a heated solid X. All right, so steam, where is steam actually? So steam is in water here. Water is H2O, but in the presence of heat, it basically causes the water to evaporate or even boil. Okay, and then that's where steam can pass through. Okay, so here you need to remember, what is reacting with steam? Right? Can I have a compound reacting with steam? Okay, so I need to recall a metal can react with steam, right? Then steam will give me metal oxide. And then all the reactions of acids with steam, with water, with acids will give me, all the reactions with metals, acid, steam, water will all give me hydrogen. Okay, so that's how I can also identify gas Y will be hydrogen, right? And which are the metals that can react with steam? Okay, now this part here, remember iron and above. Okay, iron and above, so that means lead below cannot react. Okay, so lead and below, lead, after lead is hydrogen, after hydrogen is copper, and then silver, and then gold. So cannot. So our best answer would be D. Okay, so you have to still pay attention to which metals react with cold water or steam or not at all. Right? Okay. For question 4, this is quite similar to the notes that we have. Okay, so the notes on page 20, you can refer to the explanation. I will not look at this. You can refer to page 20. Right. So I'll move over. Okay. For 5, actually, for the diagram that represents the structure of an alloy, here, this is linked to probably the very beginning chapter of chemical bonding. So alloys are a mixture of metals and other elements. Okay, the structure essentially has to be of a rather irregular arrangement, because we say that alloys are actually much stronger and harder. So here it will be A. Okay. 6. This question will span over 2 pages. So which of the following will the iron nail rust more quickly? So just look out for water and oxygen present. Okay, here actually the answer is going to be A. I'll point out why the rest are not correct. Drying agent, you're going to remove water, if you recall. Okay, so remove water, no water, oxygen may be present, but rusting cannot take place. Okay. For C, rusting doesn't take place because you are boiling the water. There's no dissolved gases present. At the same time, oil will prevent any oxygen from entering. So there's only water here. Rusting will not take place. Last but not least, you're greasing the nail. So there's a protective layer. Rusting cannot take place. Okay. 7 is displacement. All right, how do I know? I see I'm adding metals STU, and over here we have them put into a solution containing iron 2 ions. All right, if it helps, you need to know that the color is a green solution. All right, if you recall learning about QA, then when you add the alkali, you will get a green precipitate. Right, this is copper. Copper is a blue. Copper 2 ions are blue. Okay, so you just imagine if I add the STU, right, and STU, 1 by 1, If the solution remains green, you tell yourself no reaction took place, right? So I put NR as no reaction. Then that just means that ST cannot displace ion. So when you can recognize that S and T cannot displace ion, means S and T are less reactive than ion. All right. So if S and T are less reactive than ion, ion will be here. S and T will be on the right side, less reactive. So similarly, if I'm looking at the last one, U, because I placed U in, there was a reaction. Actually, all the ions got displaced, right? So that means that U is more reactive. So U must be before ion. Okay, when you do the same thing, S and U are more reactive than copper. S and U are before copper. So T does not displace copper at the same time. So now I can actually pull T away and I can put copper here. Okay, and that will correspond to our answer, which is going to be D. Okay, yeah. So work fast for MCQs. All right. Okay. Let's see. The answers for these questions. Okay, later on, maybe if I can open the floor to ask if you need help with this. But I'd like to, you can get the answers from the Google Drive. Okay, I will move over to this one. Right, for this question, let me go through, okay, the first one. Okay, so for question one, I think I give you some time to get to this worksheet. Let me pull out the link. So if any of you doesn't have this yet, okay, this is the worksheet link. Okay, I'll start. So question one. So these metals, or rather metals in general, can be extracted from their ores using different methods. Just now we identified electrolysis as one for the very reactive metals. Okay. The other one that we have is to reduce using carbon. And carbon is in the form of coke. Right? So coke is present here in this question also. Okay. We don't have to deal so much with this set of information anymore. Last time we used to have this component that was tested. It has been removed like I think 2 years back. So more importantly, if we look at the, what is this? The equation, right? Over here, iron 3 oxide is this. So we can heat it with carbon monoxide, right? Actually, this carbon in the process will form carbon monoxide first. And then carbon monoxide is used to cause iron 3 oxide to become iron. Okay, calculate the mass of iron that can be obtained when we use 32,000 grams of iron 3 oxide. So if we have the mass of iron 3 oxide, first things first, find number of moles. Okay, how do you find? Take mass. If we got the molar mass, you should times or divide. Mass to moles. I don't want my mass to appear anymore. So I need to divide. Okay, divide by the molar mass. So divide by iron is 56. 56 times 2. And then oxygen is 16. 16 times 3. Okay, so using your calculator, I think it's 160. 56 times 2 plus 3 times 16. Yeah, 160 is the MR. So 32,000 grams over 160. It's not necessary for you to write down the units, but for me, I always like to write it down so that it's clearer. So in this case, I will just type it out. 32000 divided by 160, then we'll get 200. Okay, so 200 moles. Okay, so we are one step closer. What do you do next? We have now 200 moles, right? So if I were to do the MCQ, I just need to find the mass of iron. If this is 200 moles, MCQ, I need to times 2. So it will be 400. If we do this quickly, then 400 moles of iron, we can find the mass after that. Okay, but in open-ended, we'll just compare the mole ratio first. The mole ratio of iron 3 oxide to iron is going to be 1:2. We write that out, right? Then we can continue. So 200 moles will suggest that 400 moles of iron will be produced. Okay, so I'll just rewrite out first. The number of moles of iron produced will be 400, right? And then we can find the mass. Mass of iron produced by 400. Again, now I've got moles. I need to find mass. I've got my molar mass. I will need to bring out the mass multiply. Okay, for iron it's just Fe, so 56. Okay, so 400 times 56. Need to be fast in your calculator. And then that will be 22400. Okay, which is stated over here also lah, just to check your answer. All right. Some questions may ask you, leave your answers in kilograms. So be careful. All right. Always give what the question requires. Then I would probably say, oh, this is 22.4 kilograms after dividing 1,000. Okay. Right. The next question. Okay. Question 2, actually, this will involve a little bit of your knowledge about group 1 metals in periodic table. Okay, so if you are tested, then for group 1 metals, you will need to recall that lithium metal is one of like the group 1 metals. They are known as what metals? Name? Okay, alkali metals. All right. Why they are called alkali metals is because they will react with water and they will produce the alkali. And what's the alkali? Again, if I link this to what we've just learned or what we need to remember about metals and cold water, the reaction here, will it produce a metal oxide or metal hydroxide? Okay. So once again, water, water has 2 syllables, you add 1 more, hydroxide. So it's not metal oxide. Okay, so that's why over here you need to recall the general equation. Then for part A, even if the question doesn't tell you, you can identify that there will be 2 products. Okay, lithium metal reacting with cold water. So state symbol, liquid, metal solid. We will get lithium hydroxide. Lithium is similar to sodium and potassium. They have a charge of +1. Hydroxide charge is OH minus. So this will be LiOH. Okay, state symbol. It's an aqueous solution. It's an alkali. And then we have H2 gas produced. Okay, do not forget to balance the equation. That will give us 2221. This is one of those just memorize. Okay, if not, you take a bit of time to balance. For me, I memorized already. This is actually 2221. Okay. For B, describe what is observed apart from the release of hydrogen gas when lithium reacts with cold water. I don't know if you have seen the video. When you react a metal with cold water, this very reactive metal at the same time is actually very less dense than water. Okay, it sounds so funny. The density is very low, so it will actually float on water. Then it will react and it will skate around the surface of water. Okay, the gas that's produced causes it to actually move around. Okay, but apart from the release of hydrogen gas, what else can we talk about? Okay, here you need to look at the diagram. Actually, it would have been better if the question stated referring to the diagram or with reference to the diagram. Okay, the diagram that you need to focus on is this. So what are we additionally adding? 2 drops of universal indicator. Okay. So for this alkaline, right, how does it affect the color of universal indicator? Universal indicator will turn. So what's the color of the alkaline? Okay, so that will be the answer to the question. The solution will turn. You can either say purple or blue. Okay, so these are the colors, the colors of alkaline solutions when you have an universal indicator added. Okay, recall, so acids you have red, orange, yellow, neutral is green, and then there's like blue, maybe violet or indigo, but essentially just do purple for your alkaline solutions. Okay, there's no need to explain. But if let's say I need to explain, the question just says describe, right? Why I say it's purple or blue is because of the presence of, then you must say hydroxide ions. Okay, so this is linking to acids and bases. Okay, now the mole question again. So calculate the number of moles of lithium used. I think let's have a look. We have 3.5 grams of lithium, right? So this is the mass. So again, from mass, I want to find moles. I need to bring in the molar mass. So the molar mass of lithium, if you look at the periodic table, it's actually 7. Okay, 7. So here mass, I don't want the mass anymore. I need to divide, right? So the number of moles of lithium is 3.5 grams. Divide by 7. The correct unit to put is grams per mole. And that will be half a mole. Okay. So with half a mole of lithium used, the question stated that, okay, or rather, I will actually just assume that all of the metal reacted, okay, reacted in the 100 cm3 of cold water. So essentially, the question now asks, calculate the concentration of lithium hydroxide formed, right? So lithium metal, lithium hydroxide formed. If the number of moles of lithium is 0.15, what can we tell about the number of moles of lithium hydroxide formed? Okay, so we can see it's going to be the same. 2, 2. Right, so I will identify that the same number of moles of lithium hydroxide formed is the same. All right, then now in the 100 cm3 of the solution, this is essentially the volume, right? And this is the number of moles. So we can actually find an answer. What is the concentration? If your answer is in mole per dm cube. So the concentration of LiOH is half a mole. I dissolved it in 100 cm3 solution. I don't want to stay with 100. I got to convert to dm cube. Okay, and that will give me 5 mole per dm cube. There was no need for me to look at this, or at least these. Right? I could probably just need 7 for this. Okay, but anyway, just take note, if the question asks now, what is the mass concentration? Okay, go a step further, 5 mole per dm cube. Remember, to change moles to mass, I need to multiply by the molar mass. Okay, so for lithium, the molar mass will be 7, oxygen is 16, hydrogen is 1. Okay, if this is going further. Okay, going further, if the question asks for this, then this is how you do it. And we'll just take 7 plus 16 plus 1 and we multiply by 5. Okay. Whoa, that's actually quite heavy. 120 grams per dm cube. If I have like the solid form, I have to add like 120 grams to make up this same solution here. Okay. We will move on to the metals question. Okay. For this question, we are combining a few reactions together involving steam and powder. So again, steam and powder, steam and zinc. Okay, so this is a metal steam reaction. So you need to check. Okay, recall again. Okay, metal and steam gives me a metal oxide. Okay, and hydrogen gas. Right. So now when I consider this first part here, vessel 1, so steam, zinc powder. Okay, now I can take note of the gas. The gas, which is hydrogen, is gas S. Okay, so when I actually pass H2 over to the next vessel, for the next vessel, it contains copper 2 oxide. Okay, so copper 2 oxide and hydrogen. We never learned this before, but if you look at the question, they actually give you some hints. They tell you that hydrogen is going to react with copper 2 oxide, and what we will get are 2 things. One is water vapor, the other one is copper metal. Okay, water vapor and copper metal. So for part A, our answer is what we know in our prior knowledge, okay, where steam and metal will give us hydrogen. You can write either H2 or you can spell out the name. Okay, and over here, just really quickly, steam and metal. In such questions, they never ask for the symbols, don't have to write down. Okay, so zinc and metal, zinc, metal, and steam will give you the metal oxide. Okay, so the metal here is Zn2 plus, oxide ion is O2 minus. This was the similar question that we did earlier on, ZnO, then H2. Okay, so just check if your equation is balanced. 1 zinc, 1 oxygen, 2 H2, so balanced. Okay. Part C, describe an observable change taking place in vessel 2. So vessel 2, copper 2 oxide powder, actually what we'll get is water vapor after passing through hydrogen and heating, copper metal. I think the key information here is copper. Do you all know the color of copper? Are you all expected to know? So what's the color? Blue. Blue is the solution. Yeah, copper metal is a different color. Black, no. Okay, this one, you can see the copper 2 oxide powder. Copper 2 oxide is the one that is black. Okay. The copper 2 oxide powder actually turns red-brown. Yeah. In sometimes you may see it as a pink solid. Turns reddish-brown or pink. Okay, this is actually the color of pure copper. Okay. For D, now we again come back to moles. All right, so for moles, okay, vessel 1 has 0.05 moles of steam just remember it's H2O, reacted completely with zinc powder. Okay, so for a while, I think what we need to realize is actually the question is linked to what was tested in part B. Vessel 1, right? Vessel 1. Okay, always use what you have done before. Check whether you can use your previous answer to help you. So with 0.05 moles of steam, right? This is steam. So that means I will know how much zinc oxide will be formed. So according to this, I balanced it already. The mole ratio is 1:1. So actually, if I write out first, it's 1:1. So 0.05 moles of steam will react as 0.05 moles of, will react to form 0.05 moles of ZNO. Okay, then once again, mass of zinc oxide can be calculated by taking 0.05 times the molar mass of zinc oxide. Zinc is 65, oxygen is 16. Okay. Then according to calculation, 65 plus 16 times 0.05, that will give us 4.05. Okay, units, please take note, this should be in grams. Okay, so you realize when I also multiply like that, moles and per moles will cancel out, leaving behind just gram. I know some students, they're quite happy, then they'll just write down moles at the back again. Okay, so label your workings if possible, just like how I'm doing, so that it's clearer for you to understand and copy, right? So in exams also, don't compromise on your workings. Okay, right. So according to this, the question now says that if 5 grams of zinc powder was used, what is the percentage of zinc that has reacted? Okay, how am I supposed to do this? Do I just take 4.05 and then I divide by 5? No, because this is zinc oxide, but this is zinc. Okay, we will need to actually find out what is the number of moles of zinc that actually reacted first. Okay, so once again from the equation, just now I looked at steam and zinc oxide. So I just need to shift my focus and I look at zinc. And for zinc also, the mole ratio is the same as steam. Right, so the number of moles of zinc reacted will also be the same as steam, because all of them are 1:1:1:1 ratio. Okay, then now I'm closer to finding out actually what is the real mass of zinc that reacted. So in doing so, 0.05 moles, I times 65. Okay, then after this, 65 times 0.05, that gives me, let me just show you, 3.25 grams of zinc. So this was actually the real mass, the exact mass that reacted out of the 5 grams that we used. Okay, then just based on what you learn in math, the percentage of zinc that reacted, so 3.25 grams out of the 5 grams. We multiply by 100, then we take our answer over 5 times 100. Okay, so this is 65%. I will put 0.0. Okay, put 0.0 to leave my answer to 3SF. Okay, so check if you need to put the 0.0. I think you should need. Okay, it's 3 o'clock. Let me see. Okay, I'm just gonna go through this last one and then I will upload the answers on Google Drive. Okay, for question 4, so this one, just to conclude this session, we actually have this reaction. If you read or like look at the chemical equation, zinc reacting with aqueous chromium 3 nitrate, actually gives us chromium metal and zinc nitrate. Okay, so this should pop up to you as a displacement reaction where zinc and chromium, they kind of like swap positions with each other. Zinc actually formed ions, zinc 2 plus. This is also something that you have to remember. Then based on this Roman numeral here, 3, right, actually means that chromium exists as an ion at the beginning, and then it actually forms a solid. Right? So this, you need to first identify that it is displacement. Okay. Then the explanation of why this reaction can take place, this is actually going back to the syllabus where they will need you to, let me see, something like this. Deduce the order of reactivity from a given set of results. All right, so actually from here, even though I never learned about chromium, right, but I kind of know zinc. So just based on this from theory, I will therefore be able to state that zinc, right, is more reactive than chromium. So what is the conclusion? Hence, zinc was able to displace chromium from aqueous. Here you can just write down the, I think I'll just write down the formula. Okay, so forming the chromium metal and aqueous zinc nitrate. Okay. One more thing, plus points. I think you cannot run away from, I think, ionic equation. Right? So what is the ionic equation over here? Recognize that zinc is reacting, chromium ions are reacting, chromium metal forms, zinc ions formed. Nitrate ions are not reacting. They are the spectator ions. Okay. So we'll write down zinc metal. It actually forms zinc ions. And then we also have chromium ions, but Cr3 plus. And over here, we will get chromium metal forming. Okay. To end this off, actually, you just need to look at the stoichiometric coefficients. Zinc, this is 3, 3. Chromium, 2, 2. Okay, ensuring that this equation is balanced, you check the charges. From chromium ions, total of plus 6. Zinc itself is a neutral, this metal here is neutral, 0. Zinc ions, 3 times 2, also plus 6. And then the last one, there's no charge. Okay, so this will ensure or tell me that it's balanced, and this will be the ionic equation. Right. If you want to, I can flash my answer for you to take a screenshot. Where is it? Over here. All right, for part C. But if not, I will also I'll also put it on the drive lah. Okay. All right. If this session is helpful, maybe can I just get you to help me to, I think, just scan this QR code and leave a review. I think it's more of also to find out how we can improve in the subsequent lessons, sessions that are available to you free of charge. Yeah. So if you have any questions, you can ask me in the meeting chat. If not, that's all for today. I hope you benefited from this session. Goodbye.